Hi. This video record is to draw the attention on a certain mating mistake in assembly environment. Well, can explain what it is, giving an example. Well, start. First, open one of the files in which there is the model of an object. Okay, something like this. Creating the model of the objects, well, start from the first sketching stage. At the first sketching stage, for instance, this one, we select one of the coordinate planes. Well, remind you, for instance, say that it is just the part creation stage. Well, after selecting unit system and the component creation template, yes, in the environment, part creation environment, first we draw the first sketch, the first coming sketch. How? Clicking on Start Sketch button. And well, at this stage, it is the first stage actually. Select one of the coordinate planes, XZ plane or YZ plane or XY plane, to draw the first sketch. Well, you see, there is a relationship between the viewing cube, orientation cube, and the coordinate planes. Well, for instance, this plane, coordinate plane, is parallel to this surface of the orientation cube. This one is parallel to that surface of orientation cube. While drawing the first sketch on in the plane, it is coincided with one of them. Okay, creating the component, the model of the component, whatever it is, then have a relationship inherently between the principal side of the object and the surface of the orientation cube. For instance, here, this is the most left side of the object, and this surface of the cube is parallel to that principal side. This surface parallel to that principal side. This principal side is parallel to that surface of the orientation cube. In creating the views, well, for this object, for instance, start the view creation process. I selected quadrant option and then template option, and then at the view creation stage, yes, we use viewing cube, okay, to be able to direct the principal side of the object as parallel to the surface of the paper. Well, this side is parallel to that surface of the viewing cube. So, well, if it has been defined as the front side of the object, then at this stage, view creation stage, clicking on that surface of the orientation cube, viewing cube, it is parallel to the frontal side of the object, can make the front side as parallel to the surface of the paper. Yes, since initially at the first sketching stage we selected one of the coordinate planes, well, in drawing the first sketch, and correspondingly having a geometrical relationship between the principal side of the object and the surface of the viewing cube, well, easily can teach to the software that it is the side and that side view is to be created. You know, front side, top side, left side. Okay. Yes. And after making such a highlighting, then we'll say that for this component, yes, the relationship between the orientation cube and its principal sides are correct. Parallelism relationship. Well, open another model of another object. For instance, this one. Well, can say similar things. Well, this surface of the orientation cube is parallel to that side. How we had such a relationship? Remember, similarly, at the first sketching stage, selecting one of the coordinate planes to coincide the sketch plane and drawing the first coming sketch on that sketch plane inherently had a relationship between that side of the body and that surface of the orientation cube, parallelism relationship. Thanks to the existence of such a parallelism relationship at the view creation stage, can teach to the software that that is the side, and clicking on the surface of the orientation cube, viewing cube, can have that side view of the object. Okay, now after drawing the attention to that such a geometrical relationship between the principal side of the components and the surface of the orientation cube, okay, then well, I want to draw the attention to a problem in assembly environment. This is the assembly environment, and this environment, well, say that two of the components are those. Invoke them from the project folder. One of them is this, located arbitrarily first, making a click. And yes, now I invoke the model of this component. Since I created this model, okay, having a parallelism relationship between the surface of the cube and the principal side of the object, how? Via selecting the first sketch plane as coincided with one of the x, y, or z coordinate planes. Well, sure, in assembly environment, it keeps the geometrical relationship, parallelism relationship, this side parallel to this surface, that side parallel to that surface, and so on. And this is an oblique surface. Okay, then open, say, invoke the other file. It is over there. Not open, sorry, in assembly environment. Just clicking on place button and showing the address of that file. Then say open. Have this component. Right click, say OK. And then, yes, how about the rest? Some cases, students, beginners, trying to mating one component with respect to the other may be in difficulty in using the constraining tool of the software. Well, may not position one component with respect to the other correctly, and well, find this technique, although this technique is never recommended to apply, never recommended by me. Free rotation. For instance, a beginner student selected or just by chance find such an option, right click, for instance here, free rotation, okay, or clicked on this, start the free rotation process. And then, well, which one? You selected this component, and then, well, to be able to orient it with respect to the other, it sounds good using that facility, freely rotated it. But if you freely rotate this component, then this means, be aware, you break the geometrical relationship between the orientation cube at the view creation stage viewing cube and the principal side of this object. Now initially it is parallel, principal side parallel to one of the surface of the cube. But after freely rotating it, now there is no such a relationship between this orientation cube and the sides of the component. And then after freely rotating it, then say that apply the constraining process, constraining option with respect to the other. Okay, say that, for instance, this surface and that surface ought to be in relation. Well, if the one which has been indicated first still keeping the parallelism relationship, okay, with respect to the coordinate planes or with respect to corresponding to the surface of the orientation cube, it is okay, there will be no problem. But say change the order, okay, indicate the surface first and then the surface of the other. Well, you see the firstly indicated one adapted to the with respect to the secondly indicated one. Say the second indicated one is in an orientation for which there is no geometrical relationship between the coordinate planes and then it is principal sides. Why? Because that component has been freely rotated. Well, applying the constraint to bring the surface of that component with the surface of the other component, you see, also inherently break the geometrical relationship between this component and the coordinate planes as well. And then say that student said okay, apply, cancel. And then say that you see, well, for none of the components there is no geometrical relationship. The principal side of this, principal sides of the other, okay, for both of them, unfortunately there is no parallelism relationship between the orientation cube, between the coordinate planes and the principal sides of the components. Why we had such a say relationship broken or problem? Because, well, this component has been rotated freely, and thereafter the other component has been mated with respect to the one, relationship is broken. And then, well, how about the rest? Say that it is finally became the time to create the assembly drawing. Okay, start the view creation process and select the drawing paper option, and then, well, start the view creation process, clicking on base view creation button. Saying that you have first save the file. Okay, I forgot to save the file. Okay, so save it first. Yes. And then Yes, you know, to be able to teach to the software which side view going to be created, front side, top side, etc., we use orientation cube, viewing cube. Okay? Well, say that indicate the surface of the cube to direct the principal side of the assembly as parallel to the paper. But you see, although I clicked on the surface of the cube, well, the principal side of the assembly, is not parallel to the surface of the drawing paper. Try the other side. This is not parallel. Or this is not parallel. This is not parallel. Of course, if the views are created, well, like this, like that, like this one, those won't be orthographic views. Okay, well, if it is orthographic view, then the principal side of the object is to be parallel to the picture plane, parallel to the surface of the paper. But here you see none of the principal sides parallel to the drawing paper. This is a trouble. You need to create the front view of the assembly, but here, although you try to teach to the software that it is front side, but on the front view you see the frontal side is not parallel to the drawing paper. This means frontal side of the assembly is not parallel to the drawing paper, not parallel to the frontal picture plane. This is the trouble, this is the problem. What can you do? Well, the shooting method is that one. To be able to restore the parallelism relationship between the principal side of the assembly and the coordinate plane, one of the coordinate planes. So correspondingly, the relationship, parallelism relationship between the principal side of the assembly and the surface of the orientation cube, it is called viewing cube at the view creation stage. This is the thing to do. Well, select one of the components, right click and say edit. Okay, and then on one of the principal side surface of the component, it is in edit mode, take a sketch, right, new sketch, and then sketch plane. I am sure, since I indicated the principal side of this component, and sketch plane is coincided with that principal surface of the component, well, I am sure if I teach to the software that this is one of the principal side, at present you see, since the parallelism relationship has been broken, well, you see orientation cube, the surface of orientation cube is not parallel to this principal side of the component. But in sketch mode, if I bring the cursor to the vicinity of this orientation cube, okay, and then right click the mouse and then say that set current view, not as home, but select set current view as, for instance, front or top. Not so important. Select one of them. Then yes, this means you had restored the parallelism relationship between the orientation cube and that principal side of the component. And then say finish. And then clicked on return button, and then yes, sure, if I clicked on this principal surface of the orientation cube, then the principal side of the component will be parallel. Yes, after restoring the parallelism relationship, then say that this is the frontal side of the assembly. Okay, then can create the views as orthographic views. Here, of course, say there are some other constraints. For instance, say that this surface in the assembly of this component and that surface ought to be in the same plane. And then say apply. And then another constraint, say that this surface and that surface ought to be in the same plane, and so on. Yes, since I restored the parallelism relationship between the principal side of this component, indirectly the principal side of the assembly, model of the assembly, and the coordinate plane, then can create the orthographic views. This is the drawing paper and start the view creation process. Save the file, of course, updating, after updating. And then yes, you see parallelism relation is okay. Which side you're going to create? This side, or this side, or this side? Which one? Say that in this example, this is the view to create, and then the other side view, and then the other side view, and then say okay. That is it. Yes, whenever the parallelism relation between the side of the assembly and the orientation cube and indirectly the coordinate plane is broken, then yes, the method of shooting for this trouble is that take one of the components of the assembly into edit mode, and in edit mode select one of the principal side surface of the component, and then take a sketch right on it. In sketch mode, teach to the software that that side of the component is parallel to the principal side, is a principal side. How? One more time say, in sketch mode, of course, after starting the sketching stage, edit and then select the surface, then say new sketch. And in sketch mode, bring the cursor onto orientation cube and say that set current view as top or as front or as bottom or as right or as left. Select one of them. Then this selection will restore the parallelism relationship between the principal surface of the object and the coordinate plane. And after restoring the parallelism relationship at the view creation stage without any problem, can create the principal views, can create the orthographic views. Okay. The first part of this record is about restoring the geometrical relationship between the principal side of the object of the assembly and the coordinate plane of the coordinate system. Okay, it is understandable, became clear, I think, and you understood what I mean. Okay, finish this recording, and then following video record will be about some complementary things on component mating. See you then.